The graph of an ellipse is given. Match the graph to its equation. We're given this picture here of the ellipse. Before we start working this example, let's take a look at some of the features we need to pay attention to. So we've got two orientations of an ellipse that we need to pay attention to. And that's the vertical orientation and the horizontal orientation. So I've listed the two equations here. And the first equation is the horizontal orientation. And the second equation is the vertical orientation. Now, the way that I can tell the difference between the two orientations is with the value of A. I'll go into a little bit more details about that when we look at the picture, but A is always the largest value among the three, A, B, and C, for ellipses. So with A underneath X, we have, or the larger value underneath X, we have horizontal orientation, and the larger value under Y is the vertical orientation. Now I've drawn a picture of the vertical orientation. So this picture is the vertical orientation. And with the ellipse, you have a center, which we label with HK. And because this is a vertical orientation, we're going to focus along the vertical axis for most of the important features of this graph. And what you'll find is that we have foci that are above and below the center, equal distance, that distance of C away. So the distance between the center and the focus is C. And then a little bit further along, we have two vertices. Those vertices are equal distance, a distance of A. So the distance between the center and the vertex is A. And then going perpendicular to that, we have what we call the minor axis. And these minor axis vertices, and those will have a distance of B from the center. So if we were to have an ellipse that had a horizontal orientation instead, you would have a center. A little further out, you would have foci. Those foci would be C away from the center. A little further out, you would have your vertices, and those would be a distance of A from the center. Then going in the perpendicular direction, you'd have your minor axis vertices, and those would be a distance of B away from the center. Now remember I mentioned that A is always the longest, so I've drawn B to be closer to the center than A. And then you can see a horizontal orientation of the ellipse like that. One last thing I want to share with you all is that if I connect this focus to the vertex over here, that creates a right triangle. And with a little bit of figuring out, you can figure out that this side has a length of A. We have three sides of a right triangle. We know Pythagorean theorem allows us to relate those sides. So we can say that B squared plus C squared equals A squared because of the relationship between those sides. And that's why you see these equations next to the equation of the ellipse, because those sides can be related to each other. Now we can try this problem. The graph of an ellipse is given. Match the graph to its equation. So for this example, we can see that this ellipse has a vertical orientation. So we know that we're going to use this equation, the second one, x minus h squared over b squared plus y minus k squared over a squared equals 1. And then looking at the graph, we can figure out what a is. We have a center at 0, 0, and these vertices are here and here, and we can count 1, 2, 3, a distance of 3 away, so a is equal to 3, and then going in the horizontal direction, we can see that that's 1 unit away. Our minor axis vertices is 1 unit away, so b is 1. And with that information, we can work out our equation. So let's fill in the blank here. We have x minus 0, because the center is at 0, 0, over 1 squared, b squared, plus y minus 0 squared, over 3 squared, that's a squared. And we're going to simplify that to become x squared over 1, plus y squared over 9 equals 1. And then finally, x squared over 1 is 1. So we have x squared plus y squared over 9 equals 1. And that is the equation of the ellipse that is shown in this picture. Thank you for checking out my videos. Have a great day.